So this is going to be lesson 2.4, quadratic formula, lesson 2.4. So go ahead and write that out there to the side, 2.4, quadratic formula. We're on page 10. Everybody's there with me? We use the quadratic formula because some problems cannot be solved by factoring. So we're used to seeing a problem like this, x squared minus 6x plus 4. So if I gave you this problem and I said solve it, let's try to see what happens when I use the x factor. So if I try to x factor this, what two numbers multiply to get 4 and add to get a negative 6? That's what we would be doing, right? So the only numbers that make 4 are 1 and 4 and 2 and 2. Do any of those add together to get 6? Okay, so previous to this lesson, we would be stuck at this point and say, I'm not sure how to continue, I can't factor it. So in problems where you cannot factor, the quadratic formula will work, always, okay? Even in problems that can be factored, like number 11 and 12 that we just did, you can use the quadratic formula if you see an equal sign. If there's no equal sign in the problem, you cannot use the quadratic formula. It's to solve something. So what I want to talk about is where they get this A, B, and C from. So over here to the side, let's give ourselves a reminder of standard form. Okay, so standard form, remember we do f of x equals ax squared plus bx plus c. This formula looks familiar to us, right? This is standard form, and notice this is where our A, B, and C are going to come from, okay? If you look in the big formula here, it looks kind of intimidating. This just means the opposite sign of B. We've dealt with that before when we were graphing, right? So whatever this B is, you're going to plug in the opposite sign. Plus or minus. We need plus or minus because have you noticed that all the problems we're doing, we've been getting two answers, right? Negative 1 and 5, 2/3 and 4/5. We've been getting two answers. It's because a parabola crosses the x-axis 2 times. That's the whole reason that we've been getting two answers. So this plus minus means you're going to get two answers, okay? Because that's the definition of a quadratic. X squared means you're going to get two answers. All right. Then no, you don't have to write that down. Just understand that that's why you have to have two answers. The square root of b squared minus 4ac, all divided by 2 times a. This 4ac right here is all three things that are getting multiplied together. 4 times a times c. Okay? And this right here, where the negative 4ac, this comes in, that's typically where students get messed up with their sign, figuring out which sign to use if you have negatives. So we're going to talk through that and make sure that that's not going to be an issue for you. All right, so the first thing we're going to do over here is we're going to label what our A is, what our B is, and what our C is. So off to the side, I know that A is 1 because that's the number in front of x squared. B is negative 6, and C is 4. I would like you to please write the formula down. I know it's written up there, but I need it right underneath our problem. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. And now we're going to start plugging things in, okay? We're going to be really careful. Please don't jump ahead as we plug in. The first thing says the opposite of b. So my b value is negative 6. So what am I going to plug in? Positive 6. Plus or minus. Draw your big long square root. Your b value squared. So that means we're taking the negative 6 and we're squaring it. And I'm putting the square inside the parentheses. Bless you.
Thank you.
Minus 4, and I'm cutting my square root short, so I'm going to draw it longer. I'm going to extend it. That 4 is always there. times the a value, which is 1, close your parenthesis, times the c value, which is 4. This whole problem is divided by 2 times your a value, which is 1. So your division bar, your fraction bar, should spread the length of the entire problem. Not just a baby division problem, the whole thing. We are going to simplify the entire top of the fraction before we ever do any division. Okay? So that 6 out front is not going to change, so I'm just going to write 6 plus or minus. That's not going to change. Actually, let me do this in a different color so you can see. So I have 6 plus or minus. What is negative 6 squared? What are we saying? 36. Minus, go ahead and put your minus sign down. 4 times 1 is 4, and then 4 times 4 is 16. I didn't use the negative sign, I just put my subtraction sign down. This whole thing divided by what's 2 times 1? 2. We okay so far? Okay. So now we have 6 plus or minus. What is 36 minus 16? 20. Divided by 2. Everyone okay so far? Yes. All right. Now comes maybe a new part that you haven't seen before. That's called simplifying the radical. If you take the square root of 20 in your calculator, what happens? Don't just say try it.
Right?
Try it.
Actually, I'm not sure how to square root.
Okay, square root on your calculators.
2 square root 5.
Oh, on yours. So your square root button, some of you have the square root button. If you have one of the TI-30XA, you type the number first and then hit square root x.
You get a big long decimal.
So your square root button is right here. So square root. So, yep. Yep. What are we getting? Like 4.4 something?
Yeah.
Okay, so it doesn't come out evenly. So for a fraction or for a radical, that means square root, that does not come out evenly, we're going to do what's called simplifying the radical. So off here to the side, put the square root of 20. We're going to break down the radical. Oh, square root and radical. Okay, what two numbers make 20?
10 and 10.
No.
Multiplied or added?
Multiplied together make 20. 10 and 2. This is called a factoring tree. So you're going to break 20 down to 10 and 2. Now, what two numbers multiply to get 10? 5 and 2, or 2 and 5. Can you break down 2, 5, or 5 anymore? No. Okay. So we've broken this down as far as I can. Now what we're going to do is we're going to group pairs together. So do I have a pair of anything underneath here? I have a pair of 2. So I'm going to circle this 2 and this 2. And I'm going to group them together. For every pair that you have, one of them gets written on the outside of the square root. So I have a pair of 2's. So I'm going to write only 1 2 on the outside. What's left that did not get broken down? The 5, not the 10, right? Because we broke the 10 down. Just the 5. So this becomes 2 radical 5. That's called simplifying the radical. Watch what happens, though, if I had chosen 4 and 5. Right? Because doesn't 4 times 5 make 20 as well? Does 4 break apart? 2 and 2. I'm looking for a pair of 2 things. I have a pair of 2's here, right? For every pair, you write it on the outside. 5. What do you notice? Same thing. So whether you use 4 and 5 or 10 and 2, it doesn't matter. Okay? However you decide to break it down. In my head, 4 and 5 came first. I heard most of you say 10 and 2. It doesn't matter. Same thing. Okay? So the square root of 20 can also be written as the 2 square root of 5. So we're going to write 6 plus or minus 2 square root of 5 over 2. So all I did was change the square root of 20 to be 2 square root of 5. It means the same thing. I just am kind of reducing my square root. Any questions so far? That's maybe a new skill, and we're going to practice that a little more. Last step is this. If there is something in each of these spots that I'm getting ready to highlight, in this spot, and this spot, that can be reduced. Oh, you can't see that on yours. There it is, those three things. You see those three blue dashes that I made? If there's a number that can be reduced out of all three of those positions, you'd reduce it. So can you divide something out of 6, 2, and 2? 2, right? Okay, so we're going to divide out 6, 2, and 2 by 2. That becomes a 3. Do you think we have to write the 1? Isn't 1 times anything still itself? Yeah. So we don't really have to write 1 square root of 5. We can just write square root of 5. Do we need to write divided by 1? No. This is your answer for x. 3 plus or minus the square root of 5. It does seem like a lot. This is your first time doing it. It's why it took us a while. You're going to get faster at these. Okay? Any questions before we do example 1? I think doing a few more of these will help us. Hang on.
When you put the 6 at the very beginning of the problem, why'd you do that?
Right here, this one?
Yes.
Because the formula says to take the opposite of b. Right here?
For x?
Yep, it says x equals the opposite of b. See that up here? Opposite of b?
Okay.
Those out front?
I got you. Okay.
Okay. All right, let's try example. Oh, Daniel?
Will we ever have to put that in for x?
No.
Okay.
You won't, because in Algebra 2, most of your answers are going to look like this, not super clean, all right? And so you're not going to have to plug back in for x. Good question. All right, let's try example 1 together. So the first thing we do is find A, B, and C off to the side. Is there enough room? So I would maybe put A, B, and C literally off here to the side, out here, okay? So we know that A is 1, B is what? 10, and C is negative 2.
Now, the 10 would be negative because...
When we plug it in, yes. So as you're writing it out, Taylor, just write it as is so you don't make a mistake, okay? Write it as is, and then, yes, when you plug it in, you are going to switch the sign. Good. Okay, let's go ahead and write our formula down. I know it's written up there, but it helps us to have it right there where we need it. Negative b plus or minus. I could sing you the song, but not feeling that today.
Yeah, I heard about that.
Oh, Daniel, did you want me to sing it then?
I'm willing to write
X equals negative b plus or minus square root of b squared minus 4ac all over 2 times a. Go Irish. It's a Notre Dame theme song. My husband's super Notre Dame-y. Okay. So now we have our formula written. Now we're just plugging in values. Okay? So let's go ahead and plug in our values. Instead of a negative b, we're plugging in what, Taylor?
A negative 10.
Good, a negative 10. I'm sorry, Olivia. I just keep standing in front of you. So we're plugging in a negative 10 plus or minus square root. Our b value is squared, so we're going to take 10 and square it. Minus 4 times 1 times negative 2. And then the whole thing, make your big long division sign, divided by 2 times 1. All right, so if I have negative 10 plus or minus, what is 100 squared? I'm sorry, I just gave you the answer. What is 10 squared? It's 100. All right. So 100. Now, here's the tricky part. Look up at my board for a minute. I have negative 4 times 1 times negative 2. How many negatives do I have up there?
2.
What is a negative times a negative? Positive. So this sign is going to be positive no matter what. Now that I have settled the sign, I figured out what sign it is, when I plug in 4 times 1 times 2, I don't need to worry about, is it a negative 4, is it a negative 2? I don't have to mess with that because I've already decided that a negative times a negative is a positive, okay? So what is 4 times 2 then? 8. All divided by 2 times 1 is just 2. Okay. I'm going to move so I don't keep standing in your way over here. All right, let's simplify. Negative 10 plus or minus the square root of 108 divided by 2. What do we need to do with that 108? Factor it, simplify it, take the square root of it. So if you want to put it off to the side over on the left beneath your ABC, that's fine. Okay, what two numbers make 108? If you don't know, you could always start with 2, right? Because it's an even number. So someone pick a number. 108 divided by what? 4. Okay, what is it? 4 and what? 4 and 27. All right, we can work with 4 and 27. What makes 4? 2 and 2. What makes 27? 9 and 3. What else can keep going? 9 makes 3 and 3. Are we done now?
Yep.
Okay, we're grouping together. I have a pair of 2s. I have a pair of 3s. And then what's left?
9 and 3.
Just this 3, right? Not the 9, right? The 9 got broken apart. Just that 3. Okay. So I have a 2 on the outside and a 3 on the outside. And then, they're going to multiply times each other. I have 1 pair of 2s, 1 pair of 3s on the outside. What goes inside?
3.
3.
So it's going to be 6 square root of 3.
Perfect. 6 square root of 3 is what that changes into.
Oh, I thought if you have a pair, like, one goes on the out and one goes in.
No.
Really,
Nope.
one cancels
One
out.
whole pair. Yep, one whole pair is gone on the outside. Okay, we'll practice that skill. So now we have negative 10 plus or minus 6 square root of 3 over 2. Remember we changed 108 to be 6 square root of 3? Okay. What's the last step now?
Reduce. What can be reduced?
Okay, it has to be in all 3 positions. Is there something in all 3 of these positions that can be reduced?
2.
Ooh.
Oh, yeah,
2, right? I can divide a 2 out of all of those things. Okay, so let's divide a 2 out. Which leaves me with negative 5 plus or minus 3 square root of 3. What's on the bottom?
1.
Just a 1. Do we need to write the bottom?
Nope.
Here's your answer.
Okay, this might be like jumping beyond this class, but one thing I asked in Miss Carolyn's class last term, she never explained because she was advanced. What are imaginary numbers inside of the square root?
I'm glad that you asked because we're going to do that in the second half of class today. Number 2. So in number 2, what do we have to do first? Ooh, Mitchell already did it. What'd you do, Mitchell?
You need to subtract your 4x.
We got to set it equal to 0 first, right? It's not set equal to 0. Okay, so we're going to subtract 4x over first. There's nothing to combine it with, so I'm just going to write it x squared minus 4x minus 11 equals 0. All right, now we're going to label A, B, and C. Our A value is 1, B is negative 4, and C negative 11. Okay, if you're pretty confident in plugging things in where they go, I'm not going to make you write this, but it is good if you want to write the formula so that you know. If you make a mistake, though, when you plug things in, I'm going to tell you that you have to write the formula. So if you're going to make a mistake, then go ahead and write the formula. If not, you can go ahead and plug in. So we have to have x equals the opposite of b. So what am I going to plug in here? The opposite of b is going to be 4. Plus or minus b value squared. So that means negative 4 squared. Minus 4 times 1 times negative 11. All divided by 2 times 1. You okay? Now, can we have a real life chat for a second? Anytime you square a negative, what is the result of that number?
Positive.
It's not negative, right? It's positive. And yet, on some of your papers, I will still see a negative 16 there. Because that's what the calculator told me, Miriam. Well, it's because your calculator follows order of operations. And when you type this into your calculator, your calculator does this first, which is 16, then applies the negative, which is negative 16. So that's why your calculator is giving you negative 16 when you plug negative 4 squared in. If you want to do it correctly in the calculator, you have to put parentheses around negative 4 and then square it. But we're all smart enough to be able to do negative 4 squared without a calculator, so please do not use your calculator for silly stuff like this. Okay.
Okay, by the way, I think we might be hitting imaginary numbers quicker than I think because
Negative 4 squared is 16. Crystal, what is a negative times a negative here?
A positive.
So this should be plus, and I've settled the sign. I don't even have to deal with it when I plug the numbers in. Remember how I talked to you guys about doing that? This is a negative times a negative. So when I plug in 4 times 1 times 11, I don't plug in any signs.
oh right, I forgot the 11 was negative. My bad. You're correct. I'm wrong.
Go ahead and say that again. I'm just kidding. I don't hear it enough at home, so, you know. My husband doesn't say that very often.
Oh, okay, I got you.
Oh, what happened to everything? What'd you say? I know, it's back. Okay, so 4 stays out there. 16 plus 44 is what?
60.
60 over 2. Okay. So what do we do with the square root of 60? We're going to not square it. We're going to break it apart. We're going to factor it, simplify it. So I put my 60 out here to the side. Go ahead and do that. Pick any two numbers that you know make 60. Break it apart. No matter which way you do it, we should get the same answer. So any two numbers that make 60, when you multiply them, did you get it?
Yeah.
Can you have two
I think that's
numbers
all you
on the
can go
inside?
down.
Yes, you can have two numbers on the inside. Yes, you do. You guys are so on it. 2 and 3. 2 and 5. So when you get done, no matter which way you did it, you should have a 2, a 3, a 2, and a 5. No matter which way you broke it down, okay? So I only have a pair of what, though? I only have a pair of 2s. And they don't have to be right beside each other. Okay? Yep. And the pair of 2s goes on the outside, but how many times do you write it on the outside? Just once. Okay? So I have a 2 on the outside. What goes inside, though? The 3 and the 5. And we're going to multiply those. 3 times 5. Okay? So then that's what the square root of 60 becomes. 2 radical 15. So I have 4 plus or minus 2 square root of 15 all over 2. Leanna? Go ahead.
Now you wanna reduce all of it by 2, well not all of
Okay.
it.
Yeah, we never touch what's underneath the square root. Even if that was like a 16 and it looks like it could reduce, you never touch what's underneath the square root. Okay? So we can reduce 4, 2, and 2 all by 2, which gives me 2 plus or minus. Do I need to put the 1 there?
No.
The square root of 15. That's fine if you did. On a scale of 1 to 5, 5 being, this is freaking awesome, I'm ready to be a math teacher, number 1 saying, what the heck did I just see? Give me a show of how you feel about this. 1 to 5, on your hands. Everyone show me. Yeah. Okay, well you both were out. Oh, goodness. Okay, all right, not bad. I'd like us to try number 4. We're going to skip number 3. Let's try number 4, okay? I'm going to have you set it up and see how far you can go. Number 4. If you're watching the video, you can pause and try number 4 and then resume. Okay, so shh. Raise your hand if you are to this point. -7 plus or minus the square root of 121. Now, we could break down 121 off to the side. We could do that. But what is 121? 11 times 11, and so that's a pair. Is there anything left to go inside? 121 is a perfect square. So this 121 just becomes the number 11. No square root anymore because it's a perfect square. So when we find the square root, we don't have to use the symbol anymore. So now I have -7 plus or minus 11 divided by 4. Notice there is no square root sign above the 11. Okay? So can we actually handle 11? We can actually do something with it.
What can we do with it?
So this plus minus means this. -7 plus 11 divided by 4. -7 minus 11 divided by 4. That's what that plus minus means. In the previous problems, we haven't done that because it's really hard to do 3 plus the square root of 5 and then 3 minus the square root of 5. There's not much that you can do with that, right? But over here, we can. So what is -7 plus 11? Mitchell?
4.
4. And 4 divided by 4 is 1. -7 minus 11 is, say that again, Ryan? -18. And -18 divided by 4 reduces to -9 over 2.
So you're going to put that in brackets?
Excellent, Haley. So we're going to put this in brackets.
I'm lost though. I don't know how.
-9 over 2, 1. Braxton, why did this one come out evenly and not like the other ones? Because the original problem could have been factored. Yes. So the very first thing to do is to try to look for factoring. If factoring does not work, that's when you use the quadratic formula.
So you factor it after you figure out if it's...
You check to see if you can do the x factor thing. If you can, then I would use factoring. If not, you use the quadratic formula. Okay? So here's the hint. When it comes out even like this, that means you could have factored it from the beginning.
We just wasted 15 minutes of our whole...
No, you practice the quadratic formula because you're going to need to use it.
It's easier for me to do than the factor.
I know, you've told me that 20 times.
I apologize, I just be repetitive.
See if it goes in the X factor.
Yeah, so you see if it goes in the x factor. If it does, then you can x factor it. So let's look at number 5. First, we need to do what with number 5?
Hold on.
Set it equal to 0. Yes, Lexi? Okay. No, I don't think, I haven't seen very many of those on there.
On the ECA?
On the AccuPlacer.
What's that?
I have the test to take for Math 136. We'll do some more practice, a lot more practice. It's still 2 weeks away. All
We
right,
have 2 weeks.
let's look at number 5. So we need to subtract 12x. So if I have 4x squared minus 12x plus 9 equals 0. Now we can go straight into the quadratic formula here, or we can see if this can x factor. What two numbers multiply to get 36, right? 4 times 9 is 36, and add to get negative 12.
6 and 6.
Negative 6 and negative 6. So do we need to use the quadratic formula here?
No.
No.
Here.
Okay, we're not going to do number 5. Let's look at number 6. Okay? Remember I told you yesterday that you need to keep your x squared positive? Okay? So if we're going to keep our x squared positive, that means everything needs to move over to the left side of the equal sign. So on number 6, we're going to move everything over to the left. So we're subtracting or adding whichever one you need to. Okay, don't just sit there and wait for me to do it. That's a big pet peeve of mine. That means you're just waiting and not doing anything. No. You can pause. Once you set it equal to 0, you can pause. We're going to add 2x. You should have 2x squared plus 9x minus 15 equals 0. If we wanted to try to x factor this, what two numbers multiply to get negative 30 and add to get 9? I don't think there are any, right? 3 and 10, that's not going to give you 9. 6 and 5, that's 11. 15 and 2. Okay, so this is not going to be able to x factor. So if it's not x factoring, what are we going to do? Quadratic formula.
The formula.
Yep. Okay, this is our last example before your homework, so make it a good one. I'm going to pause my instruction and I'm going to let you go to town. Please make sure that you put A, B, and C in the right spot. If you're watching the video, go ahead and pause and try number 6. So we're breaking down 201. We said 3 and 67. 67 doesn't break down anymore? Okay. So in this case, if you find something that doesn't break down anymore, then we just leave it as 201. Okay? So we're just going to leave it as 201.
Why?
Because you can't simplify it anymore. There's no pairs to pull out. Okay? What? You do, and what is 67 times 3? There you go. So we're back to 201, right? So our answer is just going to be this. If our square root does not break down, we just have the square root of 201. Yes?
You taught us like 3 ways now how to do this.
If the number came out evenly, right? Like in example 4, it came out evenly, so we could do it. But look at 1 and 2. They stayed as the square root, and so I couldn't break them down anymore. Okay? Hey guys, your classmates are asking questions that are important for you to hear the answer to as well. Leanna?
I don't understand how you stop. I understand it don't break down anymore, but why wouldn't you put like one on the outside or one in the...
Because in order to go on the outside, it has to have a pair. Does 67 have another 67 there? Does the 3 have another 3 there?
No.
So these are lonely numbers that don't have pairs.
So you couldn't just put them on the inside?
You could put them on the inside, and when you put them on the inside, you have 67 times 3.
Oh, which equals 201, never mind.
Yes. Yep. Okay, this is what you're doing in your homework for today. So after we get back from break, after we do our quiz, you're going to do on page 11, 1 through 6.
That's our homework.
Okay? Page 11, 1 through 6. Yep. We're going to take a short break today.